Operators are special symbols that perform operations on variables and values, right? First one is arithmetic operation, right? It is used for numeric calculation, right? If we want to get the sum of a number set, we should use plus mark. How can we represent it? X plus y, right? This is the addition of numbers. You can see output. See, this is the addition of these two numbers, right? And now, if you want to get the subtraction of a number set, we should use minus mark, right? Minus and run. You can see 6, right? Okay. I want to multiply. So I use an asterisk for that. Okay. What is the asterisk mark? This, right? Now you can multiply. See? Okay. Now I want to divide. I use a slash for that, right? One. If you want to get it in with decimal, you can do this, right? Let's see. This is the answer, right? Okay. If we want to get the remainder, we should use modulus. We can represent modulus from percentage, right? This is the modulus, right? Let's get remainder. 6, right? We can show it like this. Wait, how can we get remainder? Like this, right? Wait. We can get it like this, right? One, 12. What is the remaining? 6, right? This is the output. Okay. I want to add 1 to x. How can we? We should use increment, right? This is the increment, right? We use 2 plus marks to represent it, right? See, 2 plus marks, right? This is the increment. And this line should do this, right? Okay. Then finally output gives 90. Okay. Again I run it. See, 90 is the output, right? What about decrement? Decrement is the opposite of increment, right? Minus 1, we should use 2 minus, right? Let's run it. See? Okay, let's move on to the relational operators. Relational operators are used for comparisons. Result is true or false, right? If we want to equal some value, we use double equal like this, right? Now it should print. You can see x and y is equal, right? Therefore it should print true, right? Let's see. See, okay. Is 18 equal to 12? No. We can represent not equal using this, right? It represents not equal, right? Using this, it should print true, okay? Because 18 is not equal to 12. Therefore, we should use this. It should print the true, right? What about we use this? It should be false because 18 is not equal to 12, right? Okay. Is 18 greater than 12? Yes. We can represent greater than using greater than sign. Okay. It should print true, right? Because x is greater than 1. See. Is 12 smaller than 18? Yes. We can represent smaller than using this, right? It should print true because y is smaller than x. See, we can represent greater than or equal like this, right? X is greater than y, therefore it should print y, right? But if y equal to 18, it should print the true, right? See, because it is it says greater than or equal, right? Okay. Less than is the same. Change this y. It should give true because y is equal to x, right? What about 12? Also it should print true, right? Because y is less than x. Okay. Logical operators are used for Boolean logic, right? Let's see. First logical operator is logical AND, right? We can represent it from this. It from 2 ampersand, right? It returns true only if both expressions are true, right? Let's see this. It is true, right? What about second one? It is false because 2 is not greater than 3, right? That's why it gives false. This is false and this is true. One statement is true, that's why it gives false, right? Think both conditions must pass the test, okay? Can represent logical OR like this, right? It returns true if at least one expression is true, right? See, this is true, this is false, therefore it should return true, right? Because of this. this part, right? But if both are false, it should give false, right? If both are true, it should return the true, right? Okay, think just one enough to pass for this case, right? We can represent logical NOT using exclamation mark, right? Okay, this can reverse the Boolean value, true false, false true, right? Think, flip the result. Read this. 3 is greater than 2, right? But we added the exclamation mark in front of this statement. Okay. Therefore, it should give false, right? See, because this tells us 3 is not greater than 2, right? What about this? Wait. What about this? 3 is less than 2, right? We added exclamation mark in front of this statement, right? It means 3 is not sorry, 2 is not greater than 3, right? Therefore, it should return true, right? See, let's move on to the assignment operators, right? First up is the simple assignment operator, this way. Okay, this one is super simple, right? It assigns a value to a variable like this, int num5, right? Sorry. See, it assigns a value to a variable, right? Here, num now holds the value 5, right? That's it. Easy, right? Okay. Next, the plus equals operator, right? We can represent it like this. Okay. It's a shortcut for adding a value to a variable and sorting the result back, right? Now, num is 5, right? Instead of typing x is equal to x plus 3, we can use this, right? Plus equal 3, right? Let's see the value. It gives 8, right? Okay. Instead of typing this, we just write this, right? That's neat. Okay. The next one is subtraction and assign, right? Similarly, we have minus equals, right? Like this. Okay. It subtracts a value and update the variable. We should use this and run. Now num is 2, right? It's quick subtraction in one line. Okay. The next is multiply and assign, right? We can use this, right? This is the multiply and assign, right? It multiplies the variable by a value and stores it back. And finally, modulus and assign, right? This, okay, which gives you the remainder after division, right? Example, this, right? Okay, it should give 1, right? Now num is 1 because 13 divided by 3 leaves a remainder of 1, right? Perfect for cycles, wrapping, or checking even or odd numbers, right? Let's move on to the next topic. Bitwise operators, right? It operates on binary numbers, right? The first one is bitwise AND. Think of AND as a filter. It only keeps the bits that are 1 in both numbers, right? Say binary number of 5 is 0, 1, 0, 1, and binary number of 3, 0, 0, 1, 1. Just multiply them. 1 by 1, 1, 1, 0, 0, 1, 0, 0, 0, 0, 0. Therefore, result should be 1, right? How can we do? This is the output. Okay. See, it gives 1, right? Use this when you want to check or mask specific bits, right? The second one is bitwise OR, right? This turns a bit into 1 if either side has a 1, right? 1, 1, both are 1s. Therefore, it should give 1, 0, 1. We have 1. Therefore, it returns 1 again. 1, 0 should be 1. 0, 0 is 0, right? Now, return it to decimal values, right? This position 2's power of 0. Therefore, 1. And this 2, 1, 2, 2, right? Therefore, 4, 2, 4 plus 2 plus 1 equal to 7, right? Okay. Useful when you want to set a bit to 1, right? The next one is bitwise XOR, right? This gives 1 when the bits are different, right? Same bits should give 0 and different bits should give 1, right? 1, 1, therefore it should be 0. Different bits, therefore 1. Different bits 1. Same bits 0, right? Now, convert it into decimal value. It should be given 6, right? Run it. You can see 6. XOR is powerful for toggling or encrypting values, right? Okay. The next one is bitwise complement, right? Okay. This flips every bit 1 to 0, 0 to 1, right? We can represent 5 like this. Now flip it. Therefore, we can get this. Let's run it. See, in Java 2's complement, right? Okay, it gives 2's complement. Okay. Next, the left shift, right? This shifts all bits to the left and fills the right with zeros, like this. 5 equal to 5's binary is 0, 1, 0, 1, right? Now move these things left and fill the right with zeros. How? 1, 0, 1. Now you should include the 0 following 1, right? Like this. And you can you should convert into decimal value. It is the output of this, right? See, it is very useful for fast math operations, right? Next is the right shifts, right? Shifts bit to the right, keeping the sign bit. Each shift is like dividing by 2, right? 5, 1, 0, 1. In this time, we should add the 0, this, right? Okay, sorry for that. We never add the zeros for left side. The rightmost bit is discarded, right? It means we should delete this one and it should give 0, 1, 0, right? Now convert it into decimal. You can see the 2 as the output, right? Okay. The last one is unsigned shifts, right? Also shifts right, but does not keep the sign bit. It always fills with zeros, right? How can we get the output? This is used when you want pure bit shifting without sign interference, right? All bits move right by 2, like this. First, we should write this binary value from 8 bits, right? 1, 0, 1. Fill, we have 3. We should include 5 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Now all bits move right by 2, right? After moving this by 2, it removes this, right? And remaining this. Now let's run. It converts this value into decimal number. It gives 2, right? Okay. Oh, it should give 1, eh? Oh, right. We should move it into move right by 1. Sorry. Therefore, we should remove this one only and 3, right? Now it gives 2. Okay. Let's talk about outputs, right? Use system.out to display the text on the console, right? Like this. If we want to give from the user, we should use the scanner class and create an object from it, right? Scan. Now you should pass system in. Right, and create a variable and assign it to scanner dot next. Using next method, we can include string type values, right? Now let's print it. Okay, using south and I give it like this. My name is concatenate and call the name, right? Okay, let's run it. Now you should give the name here, right? Easily, and enter. Say my name is Isra, right? If you get something from this video, don't forget to subscribe us, like, comment, share with your friends. Bye bye.